Hello, everybody, and welcome. I'd first like to thank you for choosing to spend your time with us and joining in on our discussion, AWS Confidential Computing Capabilities to Secure Your Code and Data. My name is Arvind, and I'll be jointly presenting this session with my colleague, JD Bean. Our third speaker, Sudhir, could not join us today. All right, here's our agenda for today. I'll first be introducing what confidential computing means at AWS. We'll then introduce the different products and features within EC2 that make it possible for us to bring confidential computing to you. Some of these will be the AWS Nitro system, AWS Nitro Enclaves, and Nitro TPM. We'll then switch gears and deep dive into Nitro Enclaves, talk a little bit about its key features and benefits, and then focus a little bit on how the data flow looks like if you are to bring secure data into an enclave and process it without giving anybody access to it. I'll then talk a little bit about the prominent use cases that we're seeing emerging in the market today, and then we'll close out by introducing Nitro TPM and UEFI Secure Boot. All right, before I begin, let me ask the audience here, how many of you are familiar with confidential computing? Okay, about 10 to 15%. So,
if I could add in, a question I would ask is to the audience is how many folks out there are familiar with Nitro Enclaves? Show of hands there. Okay, we've got a few in the crowd who are familiar. All right.
All right, given that only about 10 to 15 are familiar with the concept of confidential computing, I'll start by first introducing what it is. At AWS, we define confidential computing as the use of specialized hardware and associated firmware to protect customer code and data while it's in use from any unauthorized access. In talking to customers, through a lot of discussions, we have determined that there are two distinct security and privacy dimensions for confidential compute. Dimension number one is where customers want to protect their code and data from operators at the cloud provider side, in this case, AWS. And dimension number two is where customers want to protect code and data from their own admin level users or malicious actors who could pose as admin level users, thereby shutting off any unauthorized access to code and data. Now, if you look at the picture here, you can see at the epicenter of this is the sensitive data that you're looking to process. And then there's two different layers. The outermost layer is what we call the rich compute environment, which is your standard EC2 instance today, where you have all of the things that you need for your compute, from which any AWS operator is actually prevented from accessing. So that's for you to access, that's for your admin level users to access all of your applications to run. But then if you're processing sensitive data, highly sensitive data, then you really want to shut off access from anybody. That's where the restricted environment comes into play, where you break up your code into trusted and untrusted components, and all of the untrusted components of the code could reside in the rich environment, and the trusted goes into the restricted environment where nobody has access to it. That's how we split the components, and we're going to talk about how we do that and how we bring to bear all of the confidential computing capabilities that we have on EC2 today. But why does this matter now? Why are we talking about, are my slides not moving? So why are we talking about this today? What we're seeing right now is the sheer volume of sensitive data, of highly sensitive data that's getting processed in the cloud is going up exponentially. So we're seeing a lot more workloads that process sensitive data migrate to the cloud. But as we do this, customers are now starting to handle personally identifiable information, private health information, digital assets like cryptocurrency. All of the digital transactions that take place financially are starting to move to the cloud. And these have very stringent privacy and confidentiality requirements associated with them. This is the kind of data that customers are looking to protect as they continue to process them in the cloud. So to understand confidential computing, we need to first understand what are we protecting and who are we protecting it from. Without identifying that, it's very difficult to identify the appropriate solution that you need to deploy to protect that data while it's getting processed. So let's talk a little bit about how we do it. If you recall, I talked about two distinct security and privacy dimensions when I introduced confidential compute to you. AWS Nitro system is the foundation of all of the virtualization for modern EC2 instances, and it helps to solve the first dimension of confidential computing that I talked about, where you can protect your code and data from any operator on the AWS side. And then we have AWS Nitro Enclaves and Nitro TPM, which solve for the second dimension of confidential computing. Nitro Enclaves provides a hardened and isolated compute environment to further isolate and protect your sensitive data so you can securely process it. Nitro TPM allows for cryptographic attestation and provides for the health and integrity of the Nitro instances via the TPM2 standard. I will now turn it over to JD to talk about the AWS Nitro system.
Thanks, Arvind. Hi, all. My name is JD, Principal Security Architect for EC2. And I'm going to speak a little bit right now, as Arvind mentioned, about the AWS Nitro system. Right, this is the critical underlying technical platform for all of our modern generations of EC2 instances. And it critically helps to address what Arvind mentioned as that first dimension of confidential compute. Right, that is the protection of customer workload, data, code from access by the underlying operator of the cloud infrastructure. And before we kind of dig in with exactly how that occurs, I want to speak a little bit about how the Nitro system differs from what many technologists might imagine or picture in their heads when they think about a virtualization stack. So on the left here is what I would probably draw if I were asked to draw what virtualization looks like at a high level of abstraction. You have a physical host that is, that's your system mainboard running a general purpose CPU like an Intel, AMD, or Graviton chip. And it's got some software running on it. At the base layer is the hypervisor, right? The critical piece of software that provides virtualization capability. And that can be reasonably a rather thin, lightweight, purpose-driven piece of software. But you also have some additional software running on that host in addition to your virtual machines, right? The virtual EC2 instances that customers are running their workloads on. And those pieces of software will provide different features, services to the system. Things like management, monitoring, security, and critically for a virtual machine, I/O functions. Things like networking and storage. Right? And in the traditional virtualization stack, say in the Zen world, you would run those in a privileged general purpose operating system known as DOM0. You'd have device models representing network or storage devices that would provide kind of translation and interface to a hardware stack. On the right side of this this picture here, you see the evolution of the Nitro system, what it has become over a 10-year period of sustained investment and innovation to really reinvent what virtualization can look like. I think one of the critical things you'll notice immediately looking at the right side of the system is that we now have two physical domains that have been isolated from each other at a physical level, right? You have that, continue to have that EC2 system host, continues to have those boxes in there, the virtual machines, which represent like an EC2 instance. But what you see is that a lot of the software that used to run on, say, on the main system host alongside those virtual instances have been moved into a separate physical domain, We've got networking, storage, management, security, and monitoring that are all running on separate hardware. What you do have left on the EC2 host is the Nitro hypervisor, right? This is a purpose-built, KVM-based, extremely lightweight hypervisor that provides really the core functions of CPU and memory allocation. So let's talk a little bit about, or take a little different picture at what the Nitro system really is. So fundamentally, the Nitro system is composed of 3 distinct categories of components. Starting on the left is the Nitro cards. These are discrete systems on a chip, independent computers, really, that are used to provide those services that used to run on the general purpose system mainboard, right? They're custom designed by our subsidiary Annapurna Labs to provide hardware acceleration for these virtualization stack functions, right? We have cards that provide local NVMe storage, or elastic block storage, EBS, networking, monitoring, and security functions for the EC2 system. They are effectively a microservices architecture of virtualization that is physically isolated and distinct from the main system. The critical technology that enables this, this feature to work really is something called SR-IOV. It allows these cards to directly communicate with virtual machines that run on the host. In the center, we have our Nitro security chip. This is a device that is integrated into that main system board, the motherboard, and it allows to protect hardware resources, right? So it can do measurement and validation of system components and state to ensure that the system is running only in a validated and approved configuration. Lastly is the Nitro hypervisor, which I mentioned earlier. And in truth, we should probably have an asterisk on the Nitro hypervisor, because the Nitro hypervisor, which powers all of our virtualized Nitro-based EC2 instances, is that lightweight hypervisor, right? It's performing really the critical functions that need to be provided for customers to have the benefits of virtualization. That's memory and CPU allocation and isolation using hardware extensions like virtualization extensions to isolate customer workloads from one another, and also really critically, isolate those workloads from itself. Alone, the Nitro hypervisor provides nearly indistinguishable performance from a bare metal system, which I find incredible. However, the reason I mentioned that the Nitro hypervisor could probably have an asterisk on it is that we also offer bare metal instances where there is no hypervisor at all. But the Nitro cards and Nitro security chip continue to function in the same way, simply removing the technical aspect of virtualization from the system. So another view here of what the Nitro system looks like. And you can see here there's a very clear split between these 2 domains. There's the main server host, the host where customer workloads run. And on the right side, we have the higher level functionalities of the EC2 system. Security, networking, storage that are provided from outside that system. At Amazon, we take confidentiality of customer data extremely seriously, and we have spent a tremendous amount of time and effort focused on rebuilding and reinventing virtualization to achieve a very critical outcome, which is that there is no operator access to the main server system in an EC2 instance. It simply does not exist in production. There is no SSH, there is no emergency button to log in and perform diagnostic functions, the entire system is operated at scale around the globe without interactive operator access of any kind. The server itself has no connection to anything other than the Nitro cards that are attached to it. The Nitro cards, similarly, do not have interactive access. Their ability to be communicated with by EC2 operators occurs over authenticated, authorized, limited purpose, audited APIs. Those APIs perform basic system functions and are critically designed to avoid any contact with customer content. So, as you can see, this entire system is really designed from the ground up to provide the kind of confidentiality and isolation from an underlying cloud infrastructure operator that we know our customers want and need. I'm going to turn things over to Arvind to introduce Nitro Enclaves, which is a really exciting feature that we've released for customers to be able to build systems like this that are hermetically sealed and zero-touch operated for themselves within their own workloads.
Thank you, JD. All right, so you heard JD talk about the Nitro system and talk a lot about isolation, no operator access. So you heard the word isolation many times, so I'm going to stick to that theme and talk a little bit more about isolation. The Nitro system already offers certain assurances with it. You already saw how the server is isolated from everything else that we built around it. What AWS Nitro Enclaves does is brings about additional isolation to your own instance, to the customer's own instance, to protect data which is in use from any unauthorized access. Now let me take you back to that server he showed you earlier, right? If you look at the box on the left here, that big white box, that's what your normal EC2 instance would look like. And everything you're seeing in this picture would have been contained within that box. Users, third-party libraries, your applications, the OS, encrypted data, and then the processing that needs to happen to convert it to plain text and then process the data. All of that would have happened on the box on the left. And that's perfectly fine with the Nitro system because it prevents us from accessing it. But what about any other unauthorized access from the customer side? The admin now has access to the EC2 instance. So if you're processing highly sensitive data and you do not want anybody to access it, then Nitro Enclaves provides the ability to additionally isolate sensitive data by creating an isolated and restrictive environment. What Nitro Enclaves allows you to do is carve out resources, CPU and memory resources, from your own EC2 instance to create that environment. The only connectivity between the enclave and the parent instance is a local channel. Nitro Enclaves does not have any network connectivity, no external connectivity, no storage, nothing associated with it. So it's highly restrictive and hardened VM. And now you can move your sensitive data while it's still in its encrypted state into the enclave and then decrypt it, revealing plain text data only to the enclave. The application that's processing this plain text data should reside in the enclave, and then it can process this data without ever revealing plain text to the parent EC2 instance. And that's how we are able to provide that additional isolation and process this data without any user ever accessing it. Once the processing is done, you can encrypt it again and use the parent instance as merely a pass-through for the data. So the parent instance never gets to see the plain text. It's always seeing encrypted data coming in and going out. The only time plain text data is getting revealed is when it's inside this isolated environment you have created for yourself. So it's very similar, if you really abstract and think about it, to the Nitro system itself, where we created isolation between us and the instance. Now you're creating isolation between you and your own instance. That's really what Enclaves is providing you. So what is an enclave and what is it not? The enclaves is really an isolated, hardened, and highly constrained virtual machine. It looks and feels a lot like a container because it's ephemeral. It spins up when you spin up your instance. It spins down when you spin your instance down. There's no storage with it. All of the application that you're looking to use to process data is contained within the enclave. But it's really not a container. It's just a VM. There is a lightweight Linux OS that runs in there, and it has its own independent kernel as well. And as I mentioned earlier, there's no persistent storage. So there's no way to bring data in there and store it and expose it to any risk. All of the processing is happening in memory. So when you spin down your enclave, all the data just goes away. There's no administrator, root, or operator access. So you cannot SSH into an enclave. There's no external network connectivity. So nobody can really try and access this enclave to read what's going on in there. So plain text data is never revealed. The enclave has its own encryption keys as well, which helps with attestation and also revealing secrets with third-party or our own other services like KMS. And we'll talk a little bit more about that as we go through the session. I'll now turn it over to JD to talk about the key features and benefits of Nitro Enclaves.
Thanks, Arvind. So, I think when you think about Nitro Enclaves, take a step back, you can really think about their key properties, features, benefits, really breaking down into 3 categories. And 2 of them I'm going to stress at the outset, which is isolation and attestation. For the rest of this presentation, we're going to spend a lot of time talking about how isolation and attestation can be used in tandem to really be applied to some very interesting and critical business use cases. But before I dig in to isolation and attestation, I want to talk about flexibility. So one of the things to understand about Nitro Enclaves is that they are processor agnostic. So although they are leveraging the hardware isolation of the Nitro system, they are agnostic to the particular chip that runs on our system board. So today they can be used with Intel and AMD-based EC2 instances, and we are working on enabling future support for Graviton-based instances. The other point about flexibility to talk about here is when Arvind mentioned the ability to carve out CPU resources and memory resources from a parent instance and to donate them to the creation of a new enclave VM, that ability is flexible and adjustable. There are certain technical limits and requirements that we could talk about in terms of increments. You must donate an entire 2 vCPUs at a time. But customers are able to strike the balance between the resources that are left and remain within the parent instance and those that are given to the enclave, depending upon their workload. So you might have an enclave with a lot of memory and a lot of CPU power, or perhaps not as much CPU power and more memory, or vice versa. The last point on flexibility is the development model to think about. It's really easy to build applications to run inside a Nitro Enclave, because Nitro Enclaves can run pretty much any kind of code that you can put in a Docker container. We use that Docker container, as Arvind mentioned, as a tool and an abstraction layer for building enclaves. But I will reiterate, enclaves are not containers. They are independent virtual machines. So let's talk a little bit about the isolation property, right? To review what Arvind went through, right? An enclave has no persistent storage, it does not have interactive access, and it does not have external networking. The sole point of external communication for a Nitro Enclave is that secure local channel back to the EC2 instance, the parent that created it. You can think of that local channel as a virtual serial cable. Uses a protocol called VSOC, which is very similar to like a Berkeley socket. that is the only mechanism of external communication for an enclave. Now let's talk about attestation. Right? Attestation is a critical ability of a Nitro enclave, which allows it to prove its identity and certain attributes of itself to an external third-party service cryptographically. That's something that customers can integrate into their own applications, but it's also something that is integrated out of the box with AWS KMS, our key management service, and AWS Certificate Manager, ACM.
JD, if I may.
Yes, please.
The one other thing that we did highlight is it comes at no additional cost to you. If you're running your EC2 instance today, you could enable Nitro enclaves, and there's no additional fee for doing that. So you could always just go and give it a spin after the session.
Yeah, so absolutely. So here we have our comic thought bubble, but I think it demonstrates the idea, right? A Nitro enclave is able to obtain a signed, cryptographically signed attestation document. The signature here is provided by the Nitro hypervisor. And the document which is signed contains things about the enclave's identity. That would include the cryptographic hash of the software that is running inside the enclave, right? That bit for bit and byte for byte, the code that is running inside this enclave is cryptographically matched to another set of code that has been validated, right? You can be sure that the code that is running inside that enclave is the same everywhere. You also can attest to other attributes, things like the parent instance that created the enclave, the ID, or an IAM role that is associated as an instance role profile with the parent instance. There are other options as well, including a scalable key signing mechanism. You're able to put into a Nitro enclave document a user-defined info, so things like cryptographic nonces, as well as the enclave's public key. Arvind mentioned this a bit earlier, and I want to emphasize the importance of this public key, right? When an enclave starts up, it can create a public-private key pair that is created in and available only to that enclave. By bootstrapping on the signed attestation document, the public key can then be distributed to external parties so that they can encrypt messages and send them to that enclave and only that enclave. Let's take a little bit a look at sort of what that KMS integration looks like, which is a really powerful accelerator for customers who want to use these attestation features. So a Nitro enclave, as we mentioned, does not have direct access to network. So with the help of a KMS proxy that we make available, customers can install an agent on the parent instance that acts as a proxy to forward communication encrypted in transit from a Nitro enclave to the AWS Key Management Service. The Key Management Service is able to understand and process and make authorization decisions based upon the enclave attestation document that's provided. So the enclave can make a request to AWS KMS to, for example, decrypt using a KMS key. KMS can ingest that request, validate the authenticity of the signed document, as well as validating the contents of that document to compare it to an AWS KMS key policy that has defined conditions. So for example, that allows customers to say, I wish for this KMS key to be used only by an enclave with a particular cryptographic hash for its code. This enclave and only this enclave may decrypt using this KMS key. This allows an enclave to decrypt data only within the bounds of that enclave in order to perform further plain text processing within the bounds of that isolated environment. to show a bit about how this flow works, what it looks like, I want Arvind to come back up to talk through how these pieces all fit together.
Thank you, JD. So you heard about what the Nitro system can do, what the enclave can do, and some of the restrictions around creating an enclave and what's attached to it and what is not, and its attestation capability as well. But what does this all mean in the real world? What does it mean when you have data you want to process? Like, how do we bring it inside the enclave? How do we process that? So we put together a short 3-step process to demonstrate that. But let's first understand the players here, right? There are 3 key players. One is the data owner. The data owner owns the highly sensitive data that they're looking to protect and process. Then we have the system administrator who manages the life cycle of the instance. So this person actually has access to the instance. And then we have the developer who develops the applications that process the data. So we have these 3 players, and the premise we are operating under is nobody trusts anybody. The data owner wants to keep the data protected, and there's no reason to trust anybody else. So let me demonstrate with a simple 3-step process how this is done. The steps in question are, number 1, fetching the data. Number 2, sending and verifying against a service such as KMS. And number 3, receiving the secrets. So step 1, and just a disclaimer here, this mock-up here shows S3 and Data Lake and KMS, but it can very well be any other service that you would choose to use. It does not have to be S3, or it does not have to be AWS KMS, but for ease of explanation, I have used that here. And also remind you that we did have first-class integration with enclaves in AWS KMS, so it's a lot easier to operate with that. Now, I'm making some assumptions here as I go through this. Number 1, that when you store the data, you're storing it as encrypted data in your S3 bucket. That's the recommended practice. And the encrypted data key, validated by KMS, encrypted by KMS, is associated with that data. And also, when JD talked about creating an enclave by allocating memory and CPU resources, there is a process that you need to follow to create an enclave, at the end of which you're left with what's called an enclave image file. That's what we use to create an enclave. So these are some basic assumptions we're making that have been followed to get here. Now, once we are here, the enclave now makes a call through the parent instance to pull the data from the data lake. At this point, the data, which is encrypted, comes into the parent instance along with the encrypted data key. So both the encrypted data and the data key come to the parent instance. Now, if I can take you back to a few slides back where I said plain text data should never be revealed to the parent instance, you can see here only encrypted data comes to the parent instance and passes through it. It then goes through the secure local channel to the enclave. So all through this process, data has not been revealed yet, and it comes into the enclave. At the same time, the enclave makes another call to receive the attestation document, which is signed by the Nitro hypervisor. This attestation document is the one JD talked about, which has all of the information about the enclave, the application that's running it, all of the PCRs are in there. So coming into this, when we talked about the encrypted data key, you also have to remember that the key policy for KMS has to be set up. So when you created the enclave, you received the hashes for it, based on which the key policy has been set up. So this attestation document that the enclave now receives has to match the key policy that you originally set up. If it doesn't match, then you know something funky's happened in between. That's the integrity of the application that's running in the enclave. That's the integrity of the enclave itself. So that's the first step, where you're fetching everything. You're fetching the encrypted data key, and the attestation document. Then the enclave sends the attestation document and the encrypted data key to KMS. KMS now verifies this attestation document against the preset key policy. It's checking for the hashes to see if they match. If they do match, then it reveals the secret to the encrypted data key and decrypts it. If it doesn't match, KMS will not decrypt the data key, so your data remains secure. But if everything is matching, then it knows all is good, and it's going to decrypt the data key. Right after decrypting the data key, KMS will now re-encrypt that data key with the enclave's public key. This is the encryption key I talked about earlier. JD touched on it when he talked about the attestation process. So the decrypted data key now gets encrypted with the enclave's public key and gets sent back. And that is the last step, where the enclave now receives the re-encrypted data key with its public key. Now it's going to check this public key against its private key and be able to decrypt that. This is when plain text data will get revealed to the enclave, and then your application can proceed to process the data. So up until this point, you notice everything stayed encrypted till the re-encrypted data key came back into the enclave for you to decrypt it and reveal plain text data. So that's how this data flows, and that's how all of the encrypted data continues to stay inside the enclave and only gets revealed inside the enclave exactly when it needs to get processed and at no other time. Once the processing is done, if you want to send encrypted data back, you just reverse work it, you encrypt it, and then send it out to the parent instance. All through this, parent instance was just a conduit. It was just acting as a pass-through for you to move your data back and forth from the data lakes. All right, I'll now turn it over to JD to talk about some real-world use cases of protecting data on code. What I showed you was a mock-up of the data flow, but there's actual real use cases that are starting to emerge in this area, which JD will talk about in more detail.
Yeah. So I hope that mock-up that Arvind walked through just now demonstrates the fundamental idea behind enclaves, or the fundamental way it can be used, right? Which is to bring sensitive plain text data inside an enclave, or to actually decrypt it inside an enclave, so that it can be processed only by trusted code within the boundaries of that isolation. Now that you have that plain text data inside your enclave, it's available, now what? So sensitive data processing is the name of the game, right, with enclaves. So you might be decrypting particularly sensitive data set that you don't want operators to have any direct access to. You might be working with sensitive cryptographic credentials and material to provide things like signing for code or documents. You might be tokenizing or detokenizing or masking or unmasking sensitive data. You might even be performing inference with a machine learning model. Nitro enclaves are a low-level compute primitive. You can do with them many of the things that you can do on a regular EC2 instance. So the what is a very, very broad answer. However, we want to walk through today a few interesting additional models that you can use with Nitro enclaves. So one of my favorite is multi-party computation or collaboration, where you have two parties now, party one and party two, that each have their own sensitive data set, an encrypted data set that they want to process and combine together in some way without providing access to the underlying data to the other. So perhaps the idea is that party one and party two have have a list, and they wish to know about the common entrants between their two lists, maybe their customer lists or membership lists. Right? Party one and party two can join together to develop and review a set of code that takes two data sets and compares them for the private set intersection between those two data sets. They can both establish independently their trust and faith that the code developed has been developed to perform the actions desired and no others. And they can then provide decrypt ability to that enclave's cryptographic hash in their KMS keys or other key management systems, so that these two parties can then run this code in a way that they can both maintain the confidence that their confidential data will remain confidential, but can still be processed together to achieve outcomes. This is a tremendously exciting possibility that opens up for customers to collaborate together. Another is the idea of protecting IP. We've talked a lot about the idea that the data we're dealing with is particularly sensitive. Sometimes the thing that is particularly sensitive, that customers or partners wish to maintain confidentiality of, might be something like an algorithm or another piece of proprietary intellectual property. The model here that we see a lot of customers really interested in pursuing is the ability to run or execute code in another account without the program or code itself being made accessible even to the owner of that account. So here you see a mock-up where we look at an architecture that allows a Bootstrap application for an enclave to be installed instead of the full application, right? It's an application that performs the bare minimum needed to obtain encrypted code, decrypt it, and run it inside the enclave. This allows you to deploy code to other accounts where you may not trust the account owner to have access to the underlying application, model, or other intellectual property. Another really, really powerful use case here is in blockchain applications, where you have multiple enclaves that might be engaged in something like co-signing a transaction. And you need to establish some degree of trust or encrypted communication between two different enclaves. Another application that we've seen a lot of interest from customers on is our integration that we mentioned earlier with Amazon Certificate Manager. Thanks to this integration, customers are now able to take an ACM managed and issued TLS certificate and provide access to it via an enclave. So for example, take your Nginx web server. It's able to communicate via PKCS11 interface to a certificate running inside an enclave. That certificate has all the same benefits that you get from an ACM managed certificate when you associate it with a load balancer, for example, where certificate rotation is managed by AWS. But you now have the ability to do that all within your own workload running on EC2. For the next segment here, I'm going to hand over to Arvind to talk a little bit about a new feature we've recently released, Nitro TPM.
Thank you, JD. All right, on May 11th, we introduced Nitro TPM. So what is Nitro TPM? To understand that, let's understand what a TPM is. Right? A TPM is a security device. It's a security device that allows you to gather and attest system state, store and generate cryptographic key data, and prove platform identity. So with Nitro TPM, which is built on the AWS Nitro system, you get the ability for EC2 instances to generate, store, and use cryptographic keys without having access to them. Nitro TPM also conforms to TPM 2.0 specification. This now allows you to migrate on-prem workloads which rely on TPM specifications to EC2. It's actually unlocked a lot of new use cases in EC2, like Microsoft BitLocker, attestation, Lux, all of these which you couldn't run on EC2 prior to this. Now you have the ability to do that and migrate those on-prem workloads onto EC2. Nitro TPM can also attest to the integrity of your EC2 instances by providing cryptographic proof via attestation documents. We saw a sample of how those attestation documents could look earlier. It's a very similar process is followed here to provide attestation documents and prove its identity. This is a feature that you can take advantage of if you're looking to leverage TPM capabilities on EC2 instances. And we launched this very recently. I encourage you to go and take a look at it on our Nitro System webpage as well. Then along with Nitro TPM, we also launched UEFI Secure Boot. This is one of those features that we launched after hearing a lot from our customers about the need to secure the boot process between multiple reboots. So if you're one of those customers that are in the habit of booting your instances on and off, and you do not want any interruptions between the boot and want to secure your instance, then UEFI Secure Boot provides you with the ability to do that. It helps to ensure that your EC2 instances run authentic software by verifying the digital signature of all the boot components. If the digital signature of the boot components do not match, then the booting will fail. So UEFI Secure Boot builds on the long-standing secure boot process that existed on EC2, just provides defense in depth for security between reboots. With that, I'll close out this session by leaving you with some resources. To learn more about Nitro Enclaves, go to go.aws/Nitro Enclaves. And for those of you that indicated that you hadn't heard about Nitro Enclaves before or haven't heard about confidential computing, we actually have a very good self-paced workshop that you could utilize to learn about enclaves, spin up your own enclaves, and give it a shot. Drop your application in there, see how to run it with Nitro Enclaves. I'll close this session out by thanking you once again for choosing to spend your time with us, and I hope this session was useful in learning about confidential computing and Nitro Enclaves. Thank you.